Okay, so here we have a palletizer gantry that's showcasing some of our products and solutions. Among those is our power and energy solutions, this is a really neat concept that we have, where we essentially are able to control the flow of power and energy, and has a bunch of neat benefits. So one of them is that if we go here, we can actually see the power coming into the system. So this is kind of the blue line right here. We actually are limiting that right now. So if I turn off this limitation, then you notice the power goes up. So what's happening there is that all of the peaks are being delivered from the grid in this case, because we don't have a limitation on there at the moment. But the application, if you look at kind of the average, it doesn't actually require that. So what we can do is, because we have these capacitor modules right here, they act as an energy buffer. And so we can essentially do peak shaving with this. And what that means is that, for example, like let's say that you had an application that would normally take a 100 kilowatt power section, you might be able to downsize that to 25 kilowatt. And that's going to be nominal, so you can reduce the size of all your conductors, your transformers, your building supply, things like that. So that's one potential benefit. Another benefit is resilience. And I'm going to put this up right here. So if you have a machine like this and you had a power failure, normally what would happen, you have high voltage, servos and brakes and things like that. The power goes out, everything stops. Uncontrolled stop. Potentially crashing if the process gets interrupted. But what we can do here, because we have this capacitance on the bus, is if I simulate some outages right here, I'm going to simulate an outage of 1 second. So we see the voltage kind of drop there. This is continuing on. It just continued moving like nothing happened. So you have like a little blip, you can ride it out. If you have a longer interruption, so let's say maybe 10 seconds, so the system still continues to run, but what it does is it sees the voltage and the charge dropping, and what it's going to do is it says, okay, I'm kind of past the point of no return. I don't know when the power is going to come back on, and so it basically just finished the move and parked itself. And so if you have a process that would have some problems if it were interrupted, you can actually come to a controlled stop and then be ready for when the power comes back. It's already back. I can just start this back up, and there it goes. So those are the two main benefits, but you also kind of get some insight into how much power each of the components are using, which can be useful. But what's interesting is normally this sort of technology, like you'll see this in larger things like port cranes, but in a smaller form factor, we can offer this like with a 25 kilowatt input and then a 10 kilowatt input. And the capacitance, we would size that to whatever your needs are.